Will you do that quickly, please? Thank you. Quickly, just sit down there if you want. Sit down there wherever you are. All right. Firstly, I need to apologize because I misread the timetable. I was looking at the second year timetable, and I thought I had an 11 o'clock class, but that's for tomorrow. Again, I'm making excuses, but please accept my apologies for doing so. This particular lecture is a Mol Med lecture. It is on acid titration and buffers. Okay? Now, I will not be able to complete the entire lecture today. So I will speak to Dr. Hanna to rearrange this lecture. Is that okay with you? At some other time is what I'm getting at. Yes? Is that okay with you? All right? So again, accept my apologies for being confused. Maybe you can put it down to my age. All right. All I want to do is, I want you to look at this problem. Can you see this problem? I'm going to give you a minute to read it. I'm going to give you a minute to read it. Can you see this problem? Read it on your own, and then I will do so later. Are you done? Yes, no? We'll give the guys up there a minute. So the problem says, or the scenario says, a 22-year-old male is planning to run a marathon when he goes to his brother in Denver. Why do you think I chose Denver and why not Riyadh? Yes? Good. I'm bringing in the issue of altitude. Okay? So Denver, which is, I do not know how high it is. Maybe you'll tell me this when I do the repeat lecture on this particular topic. But Denver is at a high altitude. Because of the high altitude, he decides to leave for Denver, okay, early to train for the event. I don't know where he lives. Maybe he lives at sea level, you know, San Diego or LA or something or the other. While in Denver, he visits an urgent care center or an emergency room after experiencing extensive cramps and spasms. Muscle cramps and spasms in his calf muscles while running, symptoms that he seldom experienced at sea level where he lives. Laboratory analysis reveals hypocalcemia. Now, I put a question at the bottom. Can you explain what's happening to this guy? Because if you can, then you understand buffers and you understand the role of acids and so on. Let's take one response. Yes, sir. No, you've got to speak for all of us. I don't know how you do that, but you're going to kind of scream. Yes. So what do you think's happening here? Does that thing work? Does it work? Yes. Sorry, what? So are you telling me the fact that he left San Diego and went to Denver, his calcium went down? Look at what I'm saying here. He says these are symptoms he seldom experienced at sea level. So when he left San Diego, You are telling me he had normal calcium because he didn't have these symptoms. So he got into a car and he drove to Colorado or Denver. And as he was driving, his calcium became lower. Yes? You mean just driving makes your calcium lower? Yes, one more hand here. Why would you think he has hyperventilation? No, I didn't hear that. Because of what? Cannot hear. So you said he is hyperventilating. Why? Because he was in a high place. Okay. He was at altitude. Okay. So what? So he's hyperventilating. Huh? His blood becomes more basic. Right. Let me see if I can summarize where you are right up to now. So the guy is at an altitude. He's hyperventilating because there's less oxygen supposedly at altitude. Yes? And because he's hyperventilating, why will his blood becomes basic? Okay, let's take this one step back. So he's hyperventilating. What gas is he exhaling? What gas is he exhaling? Huh? CO2, carbon dioxide. So he's exhaling carbon dioxide. If he's exhaling carbon dioxide, okay, that means in his blood, he's losing more carbon dioxide. Is that okay? Yes. What starts to happen to the pH of his blood because he's losing this extra carbon dioxide? In other words, what does carbon dioxide do in the bloodstream? Just stand there, please. Anybody, what does carbon dioxide do in the bloodstream? Anybody? Sorry, you got to scream. Makes what? How can carbon dioxide make something alkaline? What does carbon dioxide do in the bloodstream? Why will it make it more acidic? No. One person. Yes, sir. You had the floor. Huh? I know what acidic means. Why does carbon dioxide make the blood more acidic? Yes, sir. Good. Carbon dioxide reacts with water to give you carbonic acid. And you have an enzyme that regulates that. That carbonic acid then disintegrates into HCO3 minus and H plus. So, if you're taking this carbon dioxide and you're pushing it out, that means you're having less acid in the blood. And that is what makes the alkali. Are you okay? Did you get the mechanism now? How is that related to the calcium? Sorry, sir, what did you say? So? Proteins are ionized, you said. What charge? Negative. So the proteins in the blood will bind to what? Calcium. So if you're becoming more alkali, all right, because you are essentially losing the hydrogen ion, where does the hydrogen ion come from in the blood? We know it comes from carbon dioxide, but we're breathing the carbon dioxide out. Where will that hydrogen ion come from now? To stabilize the blood pH. Yes, sir, right at the back. And here. Yes? Yes? Since you're closer, I can't hear you. Where will the hydrogen ion come from? Yes? Yes? Huh?
Sodium channels, meaning that it's hypoexplode, so there's more sodium influx into the cell, causing hyperexcitation to the excitable tissues, causing the tizzy.
You've gone far too ahead of me. I am still dealing with the hydrogen ion. When I have carbon dioxide, I produce hydrogen ions. But I'm breathing the carbon dioxide out, so I don't have the hydrogen ions. Where will that, well, it's not that I don't, I just don't have enough. Where will the hydrogen ion come from now? Yes? What? Carboxyl group of who? Amino acids. Yes, sir. There is no electrolysis in your body to separate H2O. Goodness gracious me. Yes, the hydrogen ion is attached to the protein, the albumin. The hydrogen ion is attached to the protein. So if you are losing the carbon dioxide, thereby losing the hydrogen ion comes from the protein. That is what makes the protein more negative. Yes? Now, if the proteins are more negative, what do? Yes, sir. Good. They bind to the free calcium. If they bind to the free calcium, that decreases the free ionized calcium in blood. Yes? Are we okay so far? So this buffering capacity of blood to regulate that hydrogen ion is what's happening here. Now, let's come back to the last bit that I had. If the blood calcium is going down, why do you get these symptoms? Now give me the answer. Yes? If the calcium is going down, so what we are going to be told is, if that calcium is going down, the hypocalcemia, why will it bring about contraction of the muscles? Sorry, I interrupted. Go ahead. Stop. So we are being given a function of calcium. Okay? Haifa is telling us that calcium blocks off the sodium channels. Did you know that? Did you know that? Calcium is a regulator of the sodium channel. So if I'm losing, or if the calcium level is going down, the calcium that's blocked on the sodium channel will move out. That leaves the sodium channel, yes? So sodium, which is high outside, low inside, starts to come in. And if that happens, what's going to happen? And now you will get the spasms in the muscle. All because of a pH regulation that has gone wrong. Okay? And if you understand what's happening here and other problems, then you will understand the role of pH and buffers in the body. And I will, as I promised, I'll start off simple, and these are the things I will look at. So, we won't do this now. All right? Who's your class rep? Who's your batch, whatever they call them these days? Can you come and see me? I'll speak to Dr. Hanna and I'll tell you when this lecture has been moved to. Is that okay? Yes? I wish you all the best for your block exam next week. I think you just got one day tomorrow. Yes? All the best. And I hope it is a resounding success for you. Yes? So I will get back to your batch representative about when this class will be held. Yes? Good. Have a good lunch. We'll do it on the next class. We'll do it on the next class, on the actual day.